Okay, let's get started. So we have 1, 2, 3, 4, 5 new people. Is that right? And only one existing returning. So I guarantee we have more than just 6 people in this class, which is kind of interesting that only 5 of them showed up. But most people think the classes start next week, so that's what the issue is. You guys went to orientation yesterday? It was the day before yesterday? Oh yeah, that's right. It was Monday, wasn't it? Yeah, this is Wednesday already. So next Monday, if you're taking classes, is a holiday, you know, not to show up on that day either. So, all right, so for brand new people, which is the majority today, I have to start with the fundamentals, so you're going to be bored. But you've heard it all so many times. But let's start fresh for brand new people who don't know anything. Or it's not that you don't know anything, you just don't know how I run my classes yet. So what I'm going to do is go over the syllabus, talk about the course, talk about how to get the materials, what assignments are going to be due, how the course is going to run, all the, the first day kind of stuff. And most likely next week I'm going to have to repeat some of it because some students aren't here, obviously. So we do this for the first couple weeks. Today I'm going to do a little introductory lecture as well, just to get you started. How many people have experience programming in Java? Raise hands. 1 person? 2 people. You guys are brand new? 3. Oh, you guys, okay. You? No? You? Yes, of course. You were in my Android class, weren't you? No. It's hard to, I can't remember who's taking what. So, all right, well, this is going to be from the ground up. So if you already have programming experience in Java, you're going to be bored. If you don't have programming experience, you found the right class. Because this one is going to be from the ground up, basic Java programming. Then I'm going to get into object orientation and object-oriented features of Java. It's really hard not to talk about object orientation because Java is a pure object-oriented language. You cannot program in it in any other fashion. You have to basically use object orientation for it. So the course, and this is the syllabus that I'm looking at, and you're probably wondering, where'd you get the syllabus from? Well, I can tell you where I got the syllabus from. I got the syllabus from my website. And you're like, well, what is your website then? How did you do that? Oops, I wanted to make that bigger, not smaller. Here's the website. For brand new people, this is what you have to write down, www. Let's see if I can make that a little bigger. Let's see. Yeah, is it Control Shift Option? Ah, here we go. Yeah, I knew I could make it bigger. Can you see that from a distance? Maybe. www.bhecker.com. You don't have to put the /itu on there. It just goes there automatically. So if you just type in bhecker.com, it takes you to this lovely website. Let's see if I can get it back to normal. Oh, there it goes. There we go. Now we're back down to normal size. And I'm going to take away the summer soon and the summer exam schedule. We're kind of like in between because we're just starting in fall. But the fall 2011 will end up being the only link you see here eventually, next couple weeks. If you click on fall 2011, you're going to see the 4 classes that I'm teaching here at ITU this term. And they're actually kind of labeled in order. Are you guys taking any other classes with me? Or are you just in this class? Oh, you're also in the Unix class? Am I teaching Unix? No. Oh, data structures. Oh, that's a lovely one. The next one is what you said, the next class. Well, if you have multiple classes, you're going to be bored when you get to the next class because I'm going to go through all this stuff over again. But it's the same process for all the classes. Makes it easy, makes it consistent. So what we've got here are a link for each one of the classes. Monday, Wednesday. This particular class is also being taught on the weekends. So you could optionally attend, and there's 3 weekend sessions. If you didn't like to come on Wednesdays, and this is the only class you're taking with me on Wednesdays, and you want to get the course over with on the weekends, you're more than welcome to join us on the weekend. Although it's all day from 8 o'clock, 9 o'clock in the morning till 5 o'clock at night, and it will go all day on Saturday and Sunday, 3 times. But it's only 3 times for the entire term. It's pretty intense, but it's an option that you've got. And then I also extend the option out for the weekend people to come to the weekday session as well if they happen to. But a lot of the weekend people are traveling, so they basically have jobs elsewhere and they come to campus on only those 3 weekends. So if you click on the link here, it says both sections, so it's the same class, it just has 2 different times. Here's the link that says course syllabus on it. That's what I'm going over. We have already we have a midterm in here. This is a take home. I'll explain that. CSLOSA, I'll explain that. And course materials is your other kind of link you can click on. And you can see all of the assignments for the course. There's 5 of them. I'll go over that in a few minutes. And then you see these things called Java video tutorials. These are YouTube videos that I put together that you can access. In fact, if you click on this one, for example, Tutorial 1, Part 1, it actually takes you to the YouTube site. So this is how you can find the YouTube site. And
welcome to the first lecture.
Whoops, let's just turn that off for a second. And the YouTube channel is BJ Hecker. My middle name is Jill. So B Hecker was taken. So, and they're not even doing anything with it, which is ironic. So I would rather have that. But now I have BJ Hecker as my channel here. And if you go back, you click the back button, it takes you back to here. There's some tutorials. And then we have PowerPoint lectures that I'll be going over in the class. And then when there's a section for lecture examples, so when I go over an example, you come here, you can pick it up. And then we have the Spring 2011 archives of video recordings of previous classes from the last time I taught this course. So this is the weekend ones, and then we have the Spring 2011 weekday lectures. I'm going to make a new category right above it. It's going to be for this class. So you might not realize it, but this particular lecture right now is being recorded. So if you, what did she say about that? What was the URL? Well, you have to find the URL anyway, but let's say it's not a URL question. You found the URL, you're over here, and you're going to want to know, what did she say about that assignment? Well, you can go listen to it again. So you don't have to bring, you know, recording devices with you. You don't have to listen to anything. I mean, you can just essentially watch the video if you miss a class, came in late, you're kind of curious. I have a lot of students who like to watch the videos and then they don't come to class sometimes. I'll talk about that in a few minutes. But it's a resource for you, especially if you like the way the examples work and stuff. I also put together how-to videos on some of the assignments to give you a little heads up. So you want to basically come in here and kind of go through all of this stuff, especially for the assignments, because this how-to video right here is going to show you a lot. It's going to show you, how to put something together, essentially. So let me go back to the syllabus and talk about the course a little bit. This is, again, was downloaded from bhacker.com. So the course is going to provide an overview of Java, applications versus applets. Last time I taught the course, I never really got into applets that much. In fact, applets are kind of a thing of the past. People don't like applets anymore. So most likely I'm not going to get to applets this time around either. Not to say that there isn't any value in it, it's just there's so many other internet technologies that are being used for application development over the internet that the applet concept it's not going to earn you anything experience-wise, and you can probably figure that out on your own. But what we're going to look at is looking at, installing Java. Well, next week we'll look at that. Variables, types, expressions, control structures, language features, the AWT, Abstract Window Toolkit concept, components, events, layout managers, GUI, libraries, threads, synchronization. Never covered threads either. That's probably, I covered it a little bit last time I taught this course. It's probably more of a networking concept for the Java Enterprise Edition than it is for the SDK, JDK, and I'll explain that in a few minutes as well. Java internals, sockets, writing a server and client, if we get to it. We'll see how I usually kind of judge the level of the difficulty from the class and see. Some people have a hard time with it, some people don't. So depends on how advanced we are. So our course learning outcomes here, I'm not going to go through them, you can read them on your own. Under the required textbook, I don't actually have one. But if you're looking for recommendations on the textbook, I can give you some. The only problem with Java is like every couple of months, a new version comes out. A new update comes out, a new version. And they add a few things, they change a few things. You can find a lot of Java books on the internet. You can find a lot through Amazon used. You can find tons of resources, tutorials, everything you could possibly imagine on Java. I don't want to tie you to a book. And I don't like to teach out of a book, so you get to pick your own book if you want a book. You don't have to have a book if you don't want a book. In fact, you can probably get by just fine with all of the lecture slides and stuff I'm going to show you. I go over every one of the assignments, everything you need for it. So chances are you probably will never have an issue with not if you don't get a book. But it's totally your choice as well. So let's talk about the grading for a few minutes. This is the most important part that most students on the first day of class are primarily concerned with knowing. How am I going to be graded for this course? Well, first of all, I showed you the bhacker.com website. Okay, you're going to need access to another website called the EMS. Did you guys get training on that yet? Oh no. Well, existing people know the EMS. New people will soon discover the EMS. You also need a login for the EMS. So you can pull materials off of bhacker.com. But when you submit your work, you have to log into what's called the EMS. In fact, let me see if it's up. I go to ems.itu.edu. Actually, we have a new one. We have a new EMS coming out. This is the link to the old one. Looks like this. If you don't want to take it that way, you can go from www.itu.edu. Let's see if it brings up the same one. And you can click on up here where it says EMS login right up here in the right-hand corner. See that? Click on that. And that'll take you to the, it's the same EMS. I thought that was a new system. Have you guys been told about the new one yet? No? No new? Let's see what happens. If I log into the EMS, I'm probably going to get some blank classes right now, actually. It's probably not set up. I clicked on My Courses here. Let me do a quick search here, actually. Let me see. Java. Object-oriented. Oh, look at that, fall 2011. Look at that. 84 students in this class? It's pretty empty right now. Yeah. Eventually what you're going to end up having are some links here. The links are going to have everything that's on bhacker.com should be in here. However, this isn't normally managed correctly. Shall I say, not really managed. It's not really a management issue. It's more of an up-to-date thing. Things post faster on bhacker.com than they do in this system. Also, this system has a tendency to have a few mistakes. Something might be missing. So if you notice a problem, inconsistency, bring it to my attention. That way I know to fix it. The TAs handle this. I'm not in really control of what's going on with this EMS. However, you have to use this EMS system to submit all of your assignments, your midterm, and everything you need for this course. So you have to use the system. And it's a way of archiving everything, and you also get your grades from the system. So not a bad thing to become familiar with. But if you don't have an EMS login, you guys have EMS logins yet? No? Some knows and some yes. Don't panic. You don't need it yet. You won't need it for another month or so. So, just chill for a few. And I'll talk about when things are due in a few. And then eventually you'll get login and you'll be able to upload your stuff. So I wouldn't drop the ball. I'd get login because some of your other classes might require you to have login earlier. So you'll know. The teacher will tell you if you need the login. Hopefully. Okay, so here's some items in the grading that you want to pay attention to. We have a final exam that is going to be given in class during the final exam week, which is the last week or last 2 weeks or so of the term. Very flexible with it. I usually run it over 2 weeks, and I give you about 4 different time slots that you can come to take it. It'll take about an hour and a half to an hour. I write a new exam each term. There will probably not be any programming type questions. It's probably going to be multiple choice, fill in the blank, stuff like that. But it's a kind of an assessment that we have to do to basically require you to do some activity in class. This is not an online course. You can't just, it's not allowed actually for international students. You actually have to come to class to take this final exam. There's no excuses, no take-homes, nothing like that. The midterm exam, however, is a take-home exam, and I've actually put it out there already. So there'll be one midterm exam, which will count for 25% of your course grade, and it will be assigned halfway through, the points assigned at the halfway point in the course. It'll be a take-home exercise. In fact, it's kind of too early for you to be concerned with it, but you could see the midterm exam. eHacker.com. Let's see if I can bring that up. Here's the midterm exam. Midterm exam kind of looks like that. So it's that's the zoom in. I'm just gonna make this a little bigger. It's broken out into a couple sections. It has some where you actually have to write a few things. There's other sections where you have to answer questions with source code. And there's some questions where you have to actually look at source code and then answer some questions about it. This is the midterm that I'm going to use, actually, for this particular course. It's been updated, so it's definitely relevant. But it's not going to necessarily be due. We'll announce the due date halfway or so through the course, but it's something you can look at if you want to see the level of difficulties. It is a take-home now. The other assignment that you'll have to do is called a CSLO essay. And the CSLO essay, these are the big ticket items. So we have the midterm and the CSLO essay is about 50% of the course. And then the rest of it is the final exam and the homework assignments. And the homework assignments, before I talk about the CSLO, there's 5 of them, and they're out here as well. And I actually go over the homework assignments. Oops. They are hiding in the course materials link. And here are the assignments right here. There's 5 of them. There's tutorials about some of them. Actually, there's a couple of video tutorials on them. I actually will talk about them and go over them in class as we go there. This is a bulk of the work, but it's only 25% of your entire grade for the course. And usually, depending upon the progress through the course, I usually knock off the 5th one. In fact, I don't think the people from last time didn't have to do the 5th one. So if you're working ahead, go through 1 through 4. Skip the 5th one until I tell you whether or not it's due towards the end of the course. Because it depends on how far we get. And the 5th one has to do with an applet. So, and if we don't cover applets, I'm not going to make you do the applet assignment. But you might want to if you have an interest in learning. So yeah, but you get in what you put in, you get out what you put in. That's the theory or so. So those are a lot of work for that 25 points. The other assignment that you have is what's called the CSLO essay. And this is kind of an interesting one. It's posted out here already as well. The CSLO essay is an essay. Which is kind of interesting. Is like, why am I writing an essay for a programming course? Everybody will have what's called a CSLO course, Student Learning Objective Assignment. It might be an essay. It might be a bunch of questions you have to answer. It might be an exercise of some sort. I like to make it into a 3 to 5 page double-spaced essay. So that's double-spaced. So that's 3 pages, a page and a half, single-space. It's not a huge writing assignment, and you actually have some selections to choose from, and I'll go over this later on in the course as well. But it's a significant chunk of your grade, so you have to basically do it in order to get a passing grade. You select one of these 5 topics, and you write a paper. And the paper's going to be on, the concept of object-oriented modeling, perhaps, or the concept of web-based application tools or something. So you can kind of learn on your own through some applied research. This is a master's level course, so it's designed to kind of give you some experience doing some research, referencing your research. So the assignment actually has you create a paper in your own writing and include some reference citations. And it says here we're going to run it to turnitin.com, plagiarism checker. And you want to have at least 3 reference citations. We don't actually have a style guide for this school. Some schools use the APA, MLA, Little Brown Book. You can use any style guide that you want. If you don't know of one, I'd actually use the APA. It's a little bit more universal. But this isn't due until the last day of the course, until the last week of the course. So it's not something to worry about today, but it's something to think about in the future in terms of trying to assess what I need to do for this course. So let's see, the final exam is going to be taken a week before the final exam is given. Excuse me, a little bit of review before the final exam is given. So the week before the final exam, I'll come in here and I'll tell you everything that's going to be on the final exam. So you can study it, and then you know what to answer on the final exam. And then you'll ace the class, essentially. If you turn in all the work, and you study and do well in the final exam, you take the final exam, you're going to get an A. That's how it works. So, if you miss one of these significant chunks, you might end up with a B, or you might end up with an F. It drops from an A to an F really quickly. It depends. If you don't turn in any work, you're going to end up with an F. That's not how it's going to work. And here's the grading formula. Usually students are right here, or they're right here. So it's usually a pass or a no pass with an A. This is a graduate level course, so you need a B or above to maintain a good GPA. So most of the grading is about a B plus, A minus A. It's kind of the category I like to stick you guys in. So you can't, do all the work possible and end up with a C. I'm not going to do that to you. So if you do all the work, I'm going to grade you for your effort, essentially. One of the things that we are cracking down on is this concept of academic dishonesty. Don't like it. Don't like it when students recycle assignments. Fortunately for you, a lot of students already took this class, and you guys haven't taken it yet. And it's only been taught one time previous to this. So I can actually use the same assignments without worrying too much, because all those students are pretty much gone at this point. Or a lot of them graduated. So they're not around to share the work with you, which is good, because you don't want to share it. You don't want to cut and paste off of the internet either. Although the assignments are pretty unique, you can't really find solutions for them, and you're probably not going to want to anyway. Kind of defeats the purpose of learning. And the assignments are pretty easy compared to, some other options I could have given you. So the last page of the syllabus is the schedule here, course schedule and assignment due dates. Here's an interesting thing. I don't have due dates listed. Instead, I have the class broken out in 2 weeks. And so this is week number 1, where we're going to go an overview of Java programming, and a little introduction to object orientation, what that means. And then week 2 is going to be lecture 2 on the object concept. And you can see we kind of go through a few things. And week 3 is assignment number 1 is due. Assignment number 1 is sort of like hello world. It's not too bad. It's pretty simple, actually. And next week I'll be going over assignment number 1 for you. So it means if you follow the schedule, we've got 5 assignments. They're kind of spread out a little bit. 1 every other week is a good thing. If you don't have an EMS login, you're not going to be able to upload it into the EMS. And it's going to take a couple weeks for the EMS to even be set up. But you can save the work on it, save it on your computer, and then when the EMS, you get access and everything becomes available, you start uploading it. And I'll sort of remind you as we go through the course, hey, you should start uploading stuff. You do not want to wait until the very last week of class to upload your work. Because what ends up happening at that point is the EMS goes down. It didn't actually go down this term, which is great. Instead it got corrupted. It didn't go down, which is excellent. So at least it's staying up. But students were having issues. Links were going away. They upload something and they couldn't see it 5 minutes later. They're still working on it. And there's a new version of it out, which is supposed to fix a lot of the problems of the previous version. It has a brand new interface, more modernized, up to date. Haven't seen it yet, but it's supposed to be out for the fall. But I've noticed the classes are built in the old system, so I guess I should find out for the next couple weeks. Otherwise, we don't want to spend time putting everything in the old system if the new system is there. All right, so don't worry about having any uploading going on until you've actually, have access. And nothing is going to be counted late. Everything that is submitted before the end of the course, and I'll tell you usually towards the end of the course what the deadline is. As long as you turn it all in before that particular deadline, nothing gets counted late. And we don't actually have a late policy. We have it gets counted or it doesn't get counted. So if it's not turned in by the particular date, that's those people who get Fs because it's not going to count. It's not going to be in the system. And there's no way of submitting it after the deadline. So you're done. So it's kind of a turn it in or don't turn it in kind of philosophy that goes on around here. So hopefully that'll change in the future. I'd like students to be able to turn things in late and actually know that it was turned in late. So, but we're working on it. Any questions about the syllabus? Any questions about how to get the course materials? So you notice there's no attendance grade. I'm not going to grade you on attendance. And you don't have to sign an attendance sheet. And the TAs aren't going to be sending you nasty messages about mandatory attendance, must show up. Like they did in previous. Only the existing people know about this. New people have no idea what I'm talking about. But it is highly encouraged that you do attend the course, however. You'll learn more. Plus, if I know who you are and there's a grade dispute, I more easily opt to communicate with you and fix the problem than it is like, who are you? You're in my class? What? You didn't turn it into EMS. I'll take the class again. So it's much better if I know who you are, actually. And it's much better if you show up, actually, if you really want to learn Java. If you don't want to learn Java, that's your choice. But it's kind of a waste of money, I think. Yes? The hand going up. You'll get a login to the EMS and you'll get access to the class for which you have enrolled in.
The second class, my third class was assignment. But in the weekend, like there are so many hours classes.
Yeah. Here's how it works. You'll get access to the class that you enrolled in. So if you're in the weekday section, you'll have all of the entries for the weekday. And you just turn in anything on your own pace. But the difference is if you attend the weekend, it's just the class time that's different. All your due dates and everything are for the weekday. In fact, I keep both of them the same. The weekend due dates are the same as the week. The weekend is the same as the weekday. It's the same course. The only difference is when it meets. That one doesn't meet every week. It meets 3 times during the term. But the same final exam week, you can take the final, you can attend the weekday and take the final on the weekend. You can attend the weekend and take the final on the weekday. It's the same final exam, but they're scheduled. The weekday runs until, do I have the due date? Do I have the ending here? It runs until, it says welcome to summer. Let's go back to the ITU classes here. Looks like end of October the weekend is over with. Which means if you want to and you're a weekday student, you could take the final exam. It will be offered during the 29th, 30th weekend. You could take it totally early if you want, but most students aren't going to want to do that. They're probably going to want to take it in November-ish. I don't know when the final exams are for this particular term, but it's usually right before the holidays. Usually the semester ends before the holiday break. Also, if you have a situation in which you're traveling for the holiday or something like that, you can always take the exam early if you want. You know, let's say you can take it on the 29th or the 30th if you wanted to. But that's like 2 months away. This is really intense. It's only 3 weekends, but it's like it's going to be over with by the time. But here's the advantage you have. All of this is going to be recorded. So you as a weekday student can listen to the weekend stuff. You can listen to the weekend. People can listen to the weekday stuff. And it's kind of like shared material among both sections. It's just the time that we're physically meeting is different. So, and then the weekend students have the option of taking the exam during the final exam week for the weekday students, which is not in October, it's in November something. It's about a month later. So, that was a good question. Are there any other questions? And the only class you can really do that with is the Java course. That's the only weekend section that I'm teaching. The rest of them are just during the week. That was a good question. I forgot about that. Any other questions about the website, syllabus, assignments, course, weather, weekend, holiday plans? Anyone know about the weather this weekend? Just out of curiosity? No?
70s and 80s.
70s and 80s? You know, I was actually kind of worried this morning. There was a lot of clouds. It's actually kind of colder outside right now. It has been. Has been colder. So. Okay, now I have 14 slides to bore you. Not bore you. Give you a little introduction, overview to Java. So the way the class works is I usually, what are we supposed to end? We're supposed to end, we start at 11. We're going to keep the time. It starts at 11. And it goes until 12:30-ish. I usually get hungry about 12, 12:15, 12:30. Or I usually get tired, one or the other. Then the next class, the data structures class, starts at 2. So there's a little break between this class and the other one. Hour 45, 2 hour, approximately the lecture time, give or take, depending upon the class interest, stuff like that. Actually, I talk fast. We don't take any breaks. We could stretch it out for 3-4 hours if we wanted to, and like every hour we take a 5-minute break, 10-minute break. The only problem is I'd lose half of you. Every time you have a break at ITU, all the students go. You come back and one student's here. Wow, what happened to everybody? Oh, you took a break. So instead I give you what I call the Reader's Digest version. Are you guys familiar with the Reader's Digest version? Yeah, Cliff Notes. Familiar with that concept? Did they have Cliff Notes in India? Okay, in America, there's 2 main concepts. Students like Cliff Notes. So like when you're in grade school and they say, hey, read this book. And the book's like 200 pages long. You go, oh my God, I don't want to read this book. Here's Moby Dick, read this book. So instead you get what's called Cliff Notes, which is like 1 or 2 pages. It tells you everything that's in the book. Yeah. And then that was like the first kind of concept. And then the second one is called the Reader's Digest. Americans use it as bathroom literature. Reader's Digest gives you like a 2 or 3 page synopsis of the book. So you don't have to read the book. Because you don't have to, hopefully you're not going to spend that much time in the bathroom. It's more than just bathroom reading. I mean, people like the Reader's Digest because they can get a lot done. But it's kind of a quick way of learning everything that's in a book. It's usually fictional stuff or nonfiction or whatever, it's like, or it's like stories about dinosaurs or stories about something that interesting. They have kids versions of it too. Kids versions, adult versions of it. It's just like each story takes you about an hour or less to read, and you get the whole story. So it's for impatient Americans who don't want to read the entire book, or don't have the time, I guess. I don't know. Yeah, it's called Reader's Digest, so you learned something new today. I think the Reader's Digest is still around, but it's kind of like the newspapers have gone away. Reader's Digest was owned by a newspaper company. I don't know. I question. I should go home tonight and look it up. I'll look it up at the break. But I'd be curious to see if they're still around, because I still say, this is the Reader's Digest version, which is the entire 4-hour lecture in an hour and a half. Bang, bang, bang. There it is. All right, so what is Java? Our introduction lecture. Reader's Digest version. Well, it's developed by Sun. Okay, general purpose object-oriented language, based on C, C++. It is, actually, but it's a better version. In fact, it's based on C++. So I also teach the object-oriented programming in C++ course. And so I like to compare the two, because some students take both, or some students know about C++. And it's kind of interesting, especially a graduate level course, to kind of see the differences between the different languages. Because C++ is not truly object-oriented, although you can program in C++ and never create a class. You can't do that in Java. And Java's a better implementation of object orientation, much better. It's cleaner. But it doesn't support everything that C++ supports. As an example, there's no pointers in Java. So a lot of people are going, oh no pointers. So nobody ever does that, because everybody hates pointers. But if you have an old application that's using a pointer or something, you can't convert it to Java. There's no equivalent to it. You have to redesign the application, essentially. And C++ supports legacy C code, which uses functions and structures and all sorts of different data structures, different data structures and things that we'll see in the data structures course. But we don't see the same thing with Java. So here's another classic example, because I mentioned data structures. So if you talk about C++ in terms of its data structure support, it's practically null. It's nothing. If you want to create a stack, a queue, or something, you pretty much have to create it yourself. And it's usually pointer implemented. So, like a linked list or something. is a good example of a pointer-based list that is a form of a data structure. So everything in C++ is manually done. So Java, just import a library. Create a new list. What kind of list do you want? Oh, I want an ordered list. Okay. And it's all built in for you. So some things are easier in Java. Data structures is a classic example. It's a lot easier in the Java programming language than it is in C++. So we'll actually be creating some interesting data structures. So if you're taking the data structures course, this class will complement it well. We'll both work together, sort of. And if you're not, don't worry about it. You'll learn a little bit about data structures as well. It's pretty easy in Java. Designed for easy web internet applications, that's another huge difference. Java is internet-based development. So we have a couple versions of Java. This course is going to be on the JDK, which is the development kit for Java, not the EE version. Enterprise Edition, do not need all that. What does the Enterprise Edition give you that the JDK doesn't give you? All of the internet stuff. So we're not going to actually be developing internet applications or web-enabled applications in this course. We don't have to. Once you learn the basis of the language, the basics, then you can create as many internet-based applications as you want. It's just applying the same concept to a different thing. Actually, after you take this course, you can take the Android course and create Android apps easily. That's all written in Java. So having a little bit of Java knowledge actually helps you cross over into a lot of different development areas. Internet development, small device development, stuff like that. Anything that uses an Android platform is all written in Java. So it comes in handy for a lot of different projects and things. C++ doesn't. So you got to go the whole higher end Visual Studio if you're going to do that. And you're going to look at the Object-C, you're going to look at C# and all those other more complicated, convoluted languages that aren't quite as clear-cut. So Java definitely has a lot of selling points in its ease of use compared to everything else. A lot of people are using it. Last point on the slide here, widespread acceptance. It's the basis of a lot of development work these days. So you have better options in terms of career growth if you learn Java as a base language. Not to say that C++ is going to limit your career. It's going to actually help you because not everybody knows C. Not everybody knows C++. It's a lot harder. So probably, for special projects, it's not a bad idea to know both, actually. So here's some features. It's simple. It fixes some of the clumsy features of C++. As I mentioned before, the data structures are an excellent example. You don't have to actually create all this stuff on your own. No pointers. Garbage collection is also part of it. Automatic garbage collection. And garbage collection, we'll talk about a little bit later on in the course in terms of why we want it. Why does it become even an issue? Rich predefined class libraries. There's a lot of support. There's a lot of third-party libraries. That's how you do the Android development. You import a library. And all of a sudden you have tools to write programs for the Android application, Android platform, which is excellent, actually. It's object-oriented, focuses on the data or the objects, methods for manipulating the data. That's the conversation for next week, actually. Talk about the object concept. All of the functions are associated with objects. Almost all of the data types of objects, files, strings, potential better organization and reuse, perhaps. Actually, I like the way Java supports inheritance, because it supports inheritance and also there's an interface, and then there's a inheritance, and you can actually kind of be a little bit more creative than you can in the C++ world. C++ world, you can just, build one class from another class from another class. In Java, you can use a class as an interface. You can use a couple interface classes along with your class, and then you can extend the behavior of the class and make subclasses out of it. And that's one of the topics we'll be talking about. So we start out with the object, starting next week. We build the single line object, and then we jump right into inheritance. We build an object from an object. And then we'll take a look at interfaces, interface classes, and then we'll take a look at special applications and things that Java is useful for in terms of the library support. And then we'll take a look at, further with reuse and all encapsulation, abstraction, and all of the other object-oriented features. So it's going to give you around world-round tour of object orientation using the Java programming language as a foundation. So we will also spend some time on variables and arrays and all the other low level for those people who don't know how to program in Java. If you know how to program in any other language, like C, you know how to program in Java. The syntax is practically the same, but it's getting familiar with the concept of the class file instead of the exe. So for those people who are not familiar at all, it is an interpreted language. It's actually a hybrid. I shouldn't say it's not a pure interpreted language. So we have this thing called a JVM, Java Virtual Machine. And the virtual machine is sort of like an operating system. And you load the operating system on top of an operating system. Kind of make, why do we want to do that? Because then we can make a cross-platform compatible kind of environment where if we're creating our own operating system, when we just load that on top of something, the program always works. The .class file always loads, everything always runs properly. As an example, I have a MacBook. Everything that I do on my MacBook and I show you will work identically the same on your Windows machine. That will work identically the same on the internet, on a Linux box, on a Unix box. So the program you only compile once. It gets into what's called intermediate code, class. They call it bytecode, actually, and the bytecode gets read by the JVM, and it gets interpreted. And it runs, essentially, what's referred to as the program, which is essentially an intermediate bytecode, which is different than C++. C++, we compile and we got a .exe file. And we take the file over to XP, we run it, and it goes, error, this was compiled for Windows 7. Actually, XP and 7 are, you actually have to turn it on. Actually, if you have the .NET platform installed, you can run an XP and a 7 executable on the same platform because it's really using .NET, which is kind of a waste. If you think, in fact, I don't have .NET installed on my XP system. I don't want it installed on my XP system. It takes up half the processing power. So Java doesn't work with .NET. Instead, it works with other middleware technology that does what .NET does. But half the people that are using .NET, they don't necessarily need to have .NET installed on their computer. The only problem is the Visual Studio .NET creates everything with a .NET component. So it forces compatibility, which means if you don't have .NET installed on your computer, you got to go install it. But why? It makes my computer run twice as slow as it would if I don't have it on there. So anyway, long story short, I have a virtual machine in here that I can get through a Parallels desktop that has an XP operating system on it that does not have .NET. So in fact, when I use C++, I don't use Visual C++ because that requires .NET. So you don't have any of those problems with Java. No problems at all. You can take and compile Java. You can, in fact, if you have a MacBook, you already have a Java engine. You already have the toolkit. You have everything you need. If you have a Windows system, don't worry. You can program in Java on a Windows system as well. And next week, I'll show you the download. I'm going to show you this week because we're missing half the people. In fact, if you watch the tutorials, you'll see the download. And I'm going to use Eclipse as the IDE. So Java's free. Eclipse is free. If you don't like Eclipse, you can use NetBeans. Works on the Mac, works on the Windows system, works on everything. Doesn't matter what you're working on. So we're all on the same page. We don't have to use different platforms. Which is different than C++, modern day C++. You cannot develop on a MacBook. You are required by Microsoft to develop on a Microsoft Windows system. Can't use an Apple system for .NET, which is kind of rude actually. But that's how C++ works. So people like Java because you can develop on anything you want. So it's interpreted, so it generates bytecode, not native machine code. The compiled bytecodes are platform independent, so you can take the same applet as an example, run it from a JVM that gets started from a web browser and anything. Take the same thing, run it on a Windows system, take the same bytecode, run it on a Mac system. All runs the same, so you don't have to worry about that. Bytecodes are translated on the fly, and they're read by the JVM. This is Java Virtual Machine is what I keep calling JVM. Most of you as consumers are pretty familiar with that because you've seen those error messages when you've gone to websites. You don't have the JVM installed. And it's usually what's called the runtime engine. Well, you have to update your Java JVM runtime. So you're familiar with it from a consumer's point of view. What we're downloading and what we're going to use is the same thing, except for we have the development tools as well. So when you download the development tools, you'll get the updated JVM. It doesn't matter what JVM you run your applications on. You develop an applet the same way as you develop an application, the same way as you develop a NetBean, a Java Bean or something. It's all done the same way. So I already talked sort of about portability. The same application runs on all different platforms. The size of the primitive data types are always the same because it's running on its own operating system. Think about it. Libraries define the portable interfaces, the things that you're looking at. So some might say that Java is reliable in terms of a feature. Extensive compile time and runtime error checking. Yeah, the Java JVM does the error checking. It's an operating system. It's gonna error check everything. The Windows system doesn't know what your C++ did. It's not gonna error check anything for you at runtime. It's just gonna take the code and run it for you. So that's why you have a lot of C++ code that kind of crashes occasionally. There's nothing that's going to come back and say, missing something. Nah, it's not going to say, well, if you're lucky it says, missing DLL or something, but it's not really going to give you as much error checking or as much control. No pointer use, but real arrays are supported. Memory corruption, unauthorized memory access are impossible. So all those problems that people have with pointers and using dynamic memory allocation, impossible to have any of those problems with Java. And you don't actually have to learn any of that stuff. So it's a lot easier. What is garbage collection? When you run something in a Windows environment, it gets loaded up into memory and then the program crashes. And you have the program still loaded up into memory. So people just double click on it again and load it up one more time. But you still got stuff from the previous execution that didn't close properly, didn't get removed from memory. That's garbage. Also happens when you write a program that allocates something but never deallocates it, creates garbage. So Java's got built-in garbage collection. It actually goes out and says, is anyone using this thing? Nope, could take it out of memory. Then we're using that. It says, so it's a better memory resource manager. So you have more available memory normally, because when something crashes, it gets removed out of memory, gets cleaned up automatically. You don't have to go do it yourself. So that's one of the other selling points about Java. Also, security might also be a nice selling point. Usage of network environments requires more security. You can use C++ through a common gateway interface, a CGI interface, and you can create a web application that runs on the server, but you don't have any built-in security. In fact, it's very insecure. You're opening up the server, you're opening up a port. With the JVM running in an enterprise edition mode, so you download a different version of the JVM, essentially one that runs EE, Enterprise Edition. There's a security manager, a policy manager, a bunch of settings that you can say to say, don't allow files to be opened on remote computers, don't allow files to be saved, don't allow this, don't allow that. And you actually have a higher level of control over that, what the application's doing and what Java is doing itself. So it provides you with a lot more features than no features. So some argue and say, well, it's not really that feature rich, and then you can add on more security, SSL connections and stuff, and especially for the internet, you want to security is a huge issue these days. But it's providing more than the average programming language is doing. So it's a step up. So usage in terms of the network environment is a little bit more secure. Memory allocation model is is a major defense. And access restrictions are forced, public, private, so you can actually seal things off to the public instead of opening up a CGI port and saying, hey, come on in, run anything you want here. You can have restriction to who can run an applet, who can run an application, stuff like that. Java is multi-threaded. For anyone who's ever done any systems programming and has heard of the thread concept, usually they start going, ooh, so they shiver a little bit, and they go, oh no. Threads, it's just kind of like pointers for C++ programmers. They don't like threads for some reason. People avoid using threads for multi-threaded programming. Threads are automatically built in to Java. So everything is a thread. So it's just like pointers are automatically built in. The programmer never has to create a pointer in Java. They don't have to create a thread. You can create a thread, but you don't have to. And there's thread supports. So if you're in a Unix environment, you have P threads, POSIX threads. If you've taken a systems programming course, sometimes people do this at an undergraduate level. They take a systems programming course, sometimes mixed in with Unix, introduction to Unix and stuff, where you write a shell, or you write and it has to use a thread. You have multiple threads that have child threads, and the whole thread management is a nightmare for most people. So Java actually has a keyword called synchronize. You put that next to the method. It's synchronized. There's no inter-process communication issues. There's no threads overriding other threads or stopping execution of threads. There's none of the inter-process communication issues that you have with C++. And I'll talk a little bit more about threads. It's like the last subject that we cover in this particular course, but I'll talk about more of it towards the end of the course. We probably won't have to do the thread programming assignments. In fact, I think I took it out, actually. I think the applet's the last one. So we'll see about that as we get closer to it, but it's really simple. It's actually not too bad. So it utilizes a sophisticated set of synchronization primitives instead. We also have dynamic behavior as a selling point for Java features. Dynamic, so Java is designed to adapt to the evolving environment, which actually makes it cross-platform and also distributed. So we can move the application around, load it on different servers, have one one part of the application call another part of the application that happens to be located elsewhere. We can change the running environment. It's not set like in an executable file where we just create this file and then we have to recompile this file. Instead, we can evolve the application by adding more components to it, more objects to it. And we can change objects, interchange objects. So we can kind of evolve in terms of the environment. Libraries can freely add new methods, instance variables without affecting any of their clients. We'll talk about the client next week. We'll talk about our hello world object. But in terms of the concept, we have client classes that are the program, and we create other classes that the client runs and looks at. The client, abstractly would be like the main program, but everything in Java is separated out into classes. In fact, even hello world is a class, and a class turns into an object. But that's topics for next week when we actually start Java programming. I'm not going to give you any programming this week. Interfaces that provide flexibility as well. Reusable code specifies methods, objects, and you can check the class type in the runtime. Actually, in fact, you can see what kind of class are you, what object are you, and then you can see what objects are contained inside of the objects, and then dynamically, work with the object. That's what it is. So, as an example, if you have a line of inheritance, and the inheritance is a person. And then person is a staff person. A staff has maybe a teacher, a manager, chair. But they're all people. So you can treat the object like a person. You can treat it like a staff, or you can treat it like a higher level. So you can switch dynamically, which you can't really do in C++. Actually, not easily. You can do it, but it's a little bit more complicated. Here, it's built into the features, so it runs a lot easier. And we'll talk about that as well, in terms of some of the pros and cons of using the language. Java disadvantages. Slower than compiled language such as C. Yep, we're running it in an operating system on top of an operating system. It's going to run slower. Not significantly slower. It's gotten a lot better. JVMs have grown. They've gotten more sophisticated, but it does still run traditionally a little bit slower. You can't write a device driver in Java. Let me rephrase that. On some platforms, you can't write a device driver in Java. The Windows platform doesn't work out well. Mobile devices, you can write a device driver in Java. It's a Java-based platform, so it's all written in Java. But as an example, a low-level device driver for a piece of hardware, you're probably still going to use C and assembly language for that. It's not going to be a replacement for that type of development work. So it's got its limitations. It's usually for application development work. Essentially, you can't write a DLL in it either. You just write an application in it. Adequate for all but most times-intensive programs. in terms of its speed. So we're going to use for this class, as I mentioned before, the Java 2 platform. If you already have it on your computer, leave it alone. Even if it's not the latest and greatest version, it doesn't matter. We're not going to do anything in this class that is version specific. And if you're familiar with Java already, you know some of the I/O libraries and some of the stuff is version specific. We're not going to actually touch any of that. The only thing you might have to worry about is some, well, actually not. No, everything's pretty standard the last couple of versions. So you need any version you want. The latest and greatest would be nice. Not a bad opportunity to upgrade your system if you have it installed. Don't bother if it's a big hassle. Can be installed on different platforms, Unix, Linux, Mac, Windows. Follow the online instructions. So my first 3 tutorials are about installing Java and installing Eclipse, and I'll show you that at the end of this lecture. In terms of getting started, here's a nice little exercise. So if you decide, I want to start Java today, I had my first Java class, I want to go home and I want to write hello world today. Because some of you might be anxious to get started. You know, it's not bad. Enthusiasm, that's good. I like that. You can create some source code, and you can run the source code, and you can test your environment. And here's the problem when you install Java, especially on Windows. None of this stuff happens on the Mac system. In fact, go to a terminal window and type in Java. I wonder if I can do that here. No. Terminal window. Type in, make this a little bigger. Type in Java, and it'll come back with a bunch of stuff. That means you got it installed. If it comes back with bad command or file name, it's not working. It's not installed. So if you have a Mac, same test actually works on a Windows system, except for you don't have a terminal prompt on a Windows system. You have DOS prompt. So you go to command.com or DOS prompt icon and type in Java. You could also use Java C, type in Java C, which is the command to actually compile and see if you've got something. Sometimes Java will work, but Java C won't work. If Java works, that means the runtime JVM support is there. If Java C does not work, you don't have JDK installed. And we'll take a quick look on how to get Java in a few minutes. But let's say you've got it installed already. Let me go back to lecture 9 here. You could open up a notepad window without anything. Oops. You can open up a notepad window on your Windows system or a text editor. You don't want to use text if you're on a Mac system. You don't want to use text editor. It isn't really a text editor. Instead, you want to use Text Wrangler, or you want to use some other form that's going to actually give you a text file. You can't use Microsoft Word, and believe it or not, I've had students who've used Microsoft Word to write the source code. And then they change the name of the file from .doc to .java. And they say, how come it won't compile? Because it has stuff in there outside of text. So you don't want to use Java. You don't want to use Microsoft Word. You don't want to use WordPad. Sometimes WordPad works, sometimes it doesn't. Notepad is a good guess. It's a good text editor. Did you have a question? I thought I saw a hand. Notepad is a good editor for the Windows environment. For the Mac, Text Wrangler. Anybody here on the Mac, actually? You are. I just found this. I think you guys gave it to me. Somebody in my HTML class gave me this one here. It's called Text Wrangler. It's like the equivalent of Notepad for the Mac. If you don't want to use Eclipse. Do I have Eclipse on here? I have Eclipse on here. If you want, here's a preview of Eclipse. Any version of Eclipse will work, actually. And in fact, you can install Eclipse with Java these days. In a few minutes, I'll show you those websites. This takes a little bit longer to load, however. So it's not what I would call as fast as Text Wrangler. You saw how fast that loaded. But this is going to show you assignments. What assignments are these? Hello. Well, this is probably from the last time I taught this course. Well, we'll show you the text editor. No, usually I don't. You know what? These files may not necessarily be on here anymore. Open project. Oh, it is on here. This is going to be, I think it runs as an application. This is the fourth or fifth assignment, the text editor for this class. It's got issues. Yeah, here it does run. The good thing about Eclipse, and this is a good example of it right here, just to kind of diverge. You don't have to have this text. You can, you don't have to use a terminal window. You can exit out of that. It's not relying upon anything. And here's a GUI actually that was created. This is one of our assignments actually. This is the fourth or fifth assignment. I think it's the fourth assignment. It's actually a text editor, and it will actually run it for you. It's you get the GUI, you get everything you get with Windows, you can get with Java. The whole Windows motif. It kind of looks like, well, this screen it's using a Mac motif, but this is what we're going to get to. We're going to create this by the end of the course, essentially. And this is just a text editor. This is a text editor. You can use the type, or you can go to URLs. So let's see. I don't think that feature is actually working. No, it's not. So. Or actually, you know what? It might. I think I have to put HTTP. My colon. Let's see. Yeah, but it's bringing up. It's bringing the website up as text. It's not going to show it in HTML format. So. But as a demonstration, the interesting thing and the reason why I brought that up was to show you right from within the Eclipse browser, and I'll go through the install next week, and I'll show you everything on it. But you can make projects, you can add in your text files, you can run everything from here like I just did. So it's kind of a graphical IDE too, and it's compare this to Microsoft Visual Studio. This is a lot simpler. We have the ability to to create new Java projects and stuff, classes and objects and things automatically. And this is what I'm going to use to demonstrate most of the applications. So if you have it at home, it's probably easier. If you have it on your computer, this will work on a Windows system, no problem. And what this is, because I already went off on a tangent, I might as well just show you. If you don't have Java installed, you're going to have to install Java, obviously. And the Eclipse, I'm just going to check it real quick here. It used to have a feature where you could download it with Java. So if you went into Eclipse, it doesn't really matter what version of Eclipse you get. I went to Google and I typed in download Eclipse. And this is all demonstrated in a couple of my videos that I'll show you in a few minutes. But there's one in here. You don't want the EE. This is also explained in the video. What you want is a regular old Java. Here it is. The Eclipse IDE for Java developers, which is going to give you, because I'm on a Mac, it gives me my Mac object, my options, but it's going to give you Windows options. It works on a Windows system. And it was just promoted download. This is going to give you the interface. You're still going to need to install Java and configure Java. And to do that, you could take the age-old no-fault approach and say, install Java. If you're going to do that, type in JDK. And you're going to get the SE downloads. You're going to see this. And you're going to go basically to the Oracle website. It was made by Sun. It's owned by Oracle today. A couple of years ago, they bought the Java application. So, what you're going to want here, you don't need the FX, you don't need the NetBeans, you don't need the EE. But what you need is the JDK. So here, oh my God, they're up to 7. I think I have 5 on my, or 4. Wow, you don't need version 7. If you have something earlier than that, wow, SE7 update. So here's the two things you got going on here. you got JDK and JRE. JRE stands for Java Runtime Environment. If you're going to run Java programs, you need this on your computer. Nobody ever goes here and installs it this way. Instead, it's automated through the application. It says, hey, you're missing Java. You want to install it now? It actually goes out to here and installs this for you. If you install the JDK, you're going to get the JRE automatically. It's automatically down because you need the JDK stands for Java Development Kit. So this is going to give you Java C. It's going to give you all of the command line. And believe it or not, Eclipse is just going out and running Java C for you. When you compile it, it's just going to give you all of the command line stuff. It's a graphical user interface to it. So if you click on here, you'll see the download options for your different platforms. And you have your Windows 64 or your Windows 32-bit systems here. Make sure you download the right one, because when you get done downloading this, which takes about 45 minutes or so, half hour, 45, depending upon your connection speed, as soon as you double click on the icon, it's going to say, oh, sorry, wrong version. And you got to start over again. So it does matter which one you get, actually, which one you download. So you could start downloading this if you want. Version 7, version 6, version 5, anything you want. I would do it from the Java, from the Oracle website, though. And look for the SE. And then go and install Eclipse if you want. And if you are interested and you don't want to do it the blind leading the blind and just going through and trying to figure it out on your own, you can come into here and go into the Java class and go into the course materials, and then in this box here, how to install the Java SE. How to install the Java SE. How to configure your system, because you have to change some settings in your Windows environment. You have to add a path, you have to have that class path, and you have to make some changes, and then how to download Eclipse, how to install Eclipse. There's about 5 different videos here that will walk you through everything. So you can pause the video while your download's going, and you can follow along with the videos, and I guarantee it, you'll have everything you need installed instantly. I mean, it's foolproof. I've had people do it, and they go, oh yeah, it took me 6 months, oh, I got it installed now. Because the problem with, especially if you're working on Windows Vista, hopefully nobody's on Vista anymore, had major install issues. So it's not quite as straightforward as it should be, in my opinion. It's not like installing software on a Windows system. Java's a little bit more complex because it's not going to change your environment variables settings and stuff. So you have to add like the directory, you have to add a class path, and you have to do some system config, and you have to reboot, and do some changes essentially, which is not, if they could learn how to streamline this a little bit more, I think that would be efficient. If you download the version with NetBeans, more power to you. I hate NetBeans. But NetBeans creates the same kind of compatible file as Eclipse is going to create. The thing you have with Eclipse is that you can actually use it for Android development if you want. Install the Android toolkit and the emulator, and voila, you're creating the same tools, the same utility. You're actually now switching over and doing Android development instantly, which is not too bad, actually. So let me finish up your little how-to here. It smells like coffee, doesn't it? It smells like our food or something. Okay, so if you're overly optimistic, I'm going to go through this next week a lot slower, but if you're overly optimistic and you want to get started today because you've had your first day of Java, here's what you can do, actually. Install all that stuff I just talked about. Install the Eclipse browser, install Java. Take and create, using a text editor, open up Notepad, or open up Eclipse, start a new project, and use the main .java file. Cut and paste this stuff, and put it in the file. And you have to actually save the file with the .java extension, and the name of the file actually has to match the class, and it's case sensitive. So if you've capitalized the H in hello, the file actually has to have it capitalized as well when you save this. After you have it in there, you can go to a DOS prompt, Or a terminal prompt, as I showed you before, type in Java C, space and the name of this file. If it's not in the local directory, you have to put the path, like // wherever you saved it. It should compile. It should generate a hello world.class file. If it does, you know your tools are installed correctly. You can also use the Eclipse, what I'm going to show you next week, how to do the same thing. If you get the Java C is not recognized as an internal or external command operatable program or hatch file or anything like this, and it says command not found, your install did not work correctly. Either you downloaded the wrong item, which you may not have, or your environment variables weren't set correctly in your Windows system icon in the control panel, which the video will show you how to do. If you know you have everything set correctly, reboot your computer. It resets your environment variables just in case it didn't take the first time, it'll take the second time. Some students find that after they reboot, after they install everything, change the environment variables, everything actually syncs correctly. Depends on your firewall software, depends on your virus protection software. Sometimes when you make environment changes, they don't take instantly. You actually have to reboot in order for that stuff to the environment to be changed, because some things in the background are protecting it. So, if you see one of these errors, you have two choices. You could also specify, and I don't recommend this, specify the path for this file. This can be very long. It could be like, five lines long. In the program manager or program files /java blah blah blah. Anyway, or you can set the path environment variable, and the video will show you how to do that. If you run the program, you type in Java space and the name of the program, which is how you're going to run the program if you're not using Eclipse. And note that the command is Java, not Java C, because when you run Java, you're running the runtime environment. That's the JRE that's executing with the Java command. Java C is running your JDK that you just installed. Which is why I recommend, if you think you might have it installed, type both of these two commands and see if they work. Because this one might work without that one and vice versa. And then you have to actually put in the name without the .class extension, which is kind of weird. When you compile, you have to put the .java in there, but when you run it, you don't have to use the dot. If you put the .class in there, it gives you an error message, actually, which is kind of weird. If you get this exception in the thread, no class definition found error, that means your class path isn't set correctly. So, the purpose of this little exercise is to sort of see if you have your compiler installed correctly. Next week what we're going to do is go through, and I'm going to skip that language basics for a few minutes. Next week what we're going to go through is Hello World. Writing it from the ground up, figuring out how to write the class. The end of this lecture, which I'm going to finish next week, has some links on it if you want to look ahead. I don't recommend actually using this as a study aid. It's great for troubleshooting problems, but there are still some tutorials out there and other tutorials compiling and running simple programs. This is sort of the long way of going about it. If you went through this exercise, it's not compiling for you, it's still not working for you, grab a Java for Dummies book. Which is going to have sample source code for you already saved in text files. It's going to have sometimes you even get a disk with it, and it has all the software on it already. So, we're also going to go over this next week. So, as a recommendation, if you want, you can bring your computers with you. Not a bad idea. If we need some power strips, we can go get them. I see we only have one power in the entire room, it looks like. And I had to make a stretch over here. So, if we run out of power, we can get power strips, hopefully, and then you can actually follow along. You can download. You can, as long as we have internet access and everything, do things live. So, questions, comments, concerns? I think we've covered enough for day one then. Okay. So we're done for today. I'll see you next week at 11 for the Java course. Data structures class starts at 2. So yeah. Okay. Have lunch.